So now we will see a admittance case. Now here it is your calculated ZL 0.5 minus J. When you will take its reciprocal, you will get this one 0.4 plus J 0.8. Now you have to do all that same steps. First of all, you have to locate that value. So our value is 0.4 plus J 0.8. So start from the real axis 0.4 plus J 0.8 here. You can see this. I guess I have drawn it wrong. I have drawn it on 0.5. Sorry, 0.4 here. So I have located this one. So now what will you do? You have to draw that line here from that axis of origin. To cut this one little bit here. So take out your scales and here you will draw that line. I guess we have to do it again. Here. So now line is drawn. We have to find out our point. First of all, you have to see on which point it is. It is approximately 0. We will say that it is 0. This point here is this point here is approximately 0.115. I am taking it as my approximation. Now you have to do one thing. You have to draw, in admittance case, you have to highlight that origin circle. So I will highlight that origin circle. Sorry. It is important in case of admittance. From origin you have to draw this line. It is a little bit difficult to do these types of things on whiteboard. Okay, you have to do that same. You have to highlight that region. Again it goes ahead. Here. erase those extras. So for now we have done the highlighted region. So now what will you do? We have to draw that circle. You remember that with the help of compass. As again, you have to. I don't have compass right now in this software, so that point that it which passes through are this one, and it passes between this point. So I have to draw that circle. Let me just increase it. So that it becomes easy. Yes, it is a little bit here, and you have to go till I have drawn it wrong. You have to touch that point. Somehow I am able to draw it. Again it dislodges. I have to erase that one. I have to draw the circle, and I am unable to do it just because. So I don't know if this software has compass because I've checked a lot. So I have to join this one. So you can see that our circle is somehow created. Now what will you do? You have to make an intersecting point here. From here, and one is at here. So again I will take out my scale, and I have to draw that intersecting circle from that intersection point. I have to I guess this is my origin. Here. So I have drawn that line from that intersecting region. From point 1. Now I have to draw it again from here also now. On if you do it this on paper, it is a very smooth process, but it on here it is quite hectic and it doesn't give get accurate results. So now we have drawn that intersecting points. So as you can see that this point is 0.115 and this point is approximately 0.171. This point is 0.1. This point is approximately 0.171, and then you have to find out the distance between them. You have to minus this one with this one. You have to minus 0.115 with 0.171. You will get somehow distance here. So it is a, I forgot to tell you that it is of a admittance case and it is a single step case. So you are familiar with the process, that circle you have drawn here and now you have drawn here, and you have to make two intersecting lines here. So on paper which I have got, that intersecting point is almost 1.6, and on the negative axis it is also 1.6. So on the paper which I have got, that value is G, this value is your value of B, this is the value of B, and this is the value of G. So it's, you have to make, I guess I have done something wrong here. You have drawn that circle from point 1. No, it's okay. You will get G1 in this case. G is always 1 in this case, and B will be 1.81. So 1.82, I guess. It is a stub case. So here we are getting the value G. We have to find the value of G plus JB. So value of G here is 1 plus and it is 1 point and it is 1.8. Okay, so now you have made this intersecting line. So now in order to cancel this value in stub case, with you have to see where minus j 1.1 minus j 1.8 is. Here it is 1.8. It is actually 1.81 or 1.82, but we are taking 1.8 for simplicity. So you have to again draw another line to cancel this out, that j 1.8. You have to again see that origin here, I guess. Here. So line is not getting drawn. I will just mark it with this here. So it has lied on 1.8. So now you will see that it will cancel out this 1.8. So in order to find that distance, you can see that this is your short in admittance case, this is your short circuit side and this one is your open circuit side. So now you can see you have to measure out the distance here. I have to here. This is your point of 0.25. Now you will see this distance and that distance is 0.25 minus 0.38, this value minus this. I will write it here. It is 0.38 minus 0.25, the value of this distance, which I have located with blue pen. You can calculate it further. So this was for short circuit case, and for open circuit first let me calculate this value here. This value is 0.008 lambda, 0.0088 lambda for short circuit gate. For open circuit you just have to add this value in 0.25. That's it. So this was Smith chart for admittance case. You have done the same steps almost. Just highlight that one circle with a black marker, make intersecting points, get the values of G and JB. J is B, value of G will remain 1, but value of B is 1.8. We approximated here. Now it is a single stub case, so now you have to cancel out that value 1.8. Now locate this point here, it will be here. Locate this line, so that 1.8 will be cancelled out with minus 1.8. Now see that this point is 0.38, this is 0.25. In short circuit case you have to just minus them, you will get this value, and in open circuit you just have to add those two values, that resultant and with 0.25. And in admittance you have to take reciprocal of ZL, then locate that point here. Also you can just see those angles, see values here and minus them. In admittance, open circuit is on left side, and in In that previous case, in previous video, we have open circuit on right side. That was all about Smith chart.